for 7.4. No. A bit. All right, so we're going to do 7.4. So this is basic trigonometric equations. So zoom on in. And so this is basic trigonometric equations. So how to solve this, we're going to be doing this in steps. So we're going to call this step 1, we're going to call this step 2, this is step 3. So 1, solve the trigonometric equation. So the trig function is equal to a value. Basically it looks like this, some trig value equals something. Find the solutions in 1 period, and then we're going to find all the solutions. I guess we don't need the 2 periods, just 1's fine. Alright, so the first one is, here we're going to have sine theta equals to 1. So this is actually already this is already the way we want it, right? Okay, so here, where is sine of theta equal to pi or equal 1/2? And so here we're going to do it for 1 period. So theta 2, here we know our normal answer, which is pi over 6, right? And then the other one, which is, so here sine is positive in both the first and second quadrant, right? Alright, so this is this angle, this is this angle. So here we're going to be looking for 1 period be 2 pi for this, right? For sine and cosine to be 2 pi, for tangent and cotangent to be pi over 2, or just pi, right? So where's the 2 answers? So here's one, and the other one is over here, which is 5 pi over 6. So notice that sine equals 1/2 here and also here. Okay, so these are the 2 answers because sine is positive in the first quadrant and the second quadrant. So most of the time when you're doing sine or cosine, you're going to have to find the answers in the 2 quadrants where it occurs, because remember, in 1 period, unless it's 1 or -1, you're going to hit that number twice, right? So here it's sine of 1/2, and here if you plug in inverse, if you say theta equals to the inverse sine or arc sine of 1/2, you're going to get this angle, and then you're going to have to deduce what this angle is. Okay, and we'll go over how to do that more. So here you can just look at your chart. Your chart will give you these answers. Here, if I knew this angle is true, I can just take pi minus that angle. So pi minus this gives me 5/6. Okay, so that's how we did this one. Alright, so that's that, and then all solutions. So for secant, cosecant, sine, and cosine, we're just going to add, we're going to take our solutions here, and we're going to just add plus 2 pi n. Your book may use a k, I don't remember. I can look it up real quick, I guess, but that tells me I'm on the wrong layer. 2 pi n. Actually, let me double check how your book does it. That way I can keep in contact with your book. Alright, your book is using K. Here's this K. Alright, so this is how I write it. Your book's going to write it this way. 2k pi. It's the same. It's the exact same, right? So I think I'm going to try to mentally switch. If I don't do it every time, it's just what it is. And so here you just take pi over 6. So 5 pi over 6. So I'm going to add 2k pi. And you're going to add this 2k pi for sine. So cosine, sine, secant, and cosecant. So here, when you see this, when you want all the solutions, so if you want solutions in 1 period, your book asks for you the solution in 1 period, it's just this and this, right? Equals to pi over 6 and 5 pi over 6. So once all solutions, you're going to have to add this 2k pi. Basically, it says I'm here, and then if I went around the circle once, I'll be back here, so I get the same solution, or I'm here. If I went around the circle once, I'm back here, or if I went minus the circle once, or minus 10 of the circles. Those are all solutions, because you can keep going around and around and around, because remember that sine looks like this. It starts at 0, it goes up, goes down, goes up, and goes, and so here if I set it at 1/2, it'll hit these 2, and then it'll hit those 2, and then it'll hit these 2, and onward and forward. So there's actually an infinite number of solutions. Okay? Alright, so let's do it again. So here, let's do this, and let's discern what this is. So here, 1, this is already written the way we like it, right? It's already value and sine. So let's just do it for cosine. So cosine is negative in the 3rd and the second and third quadrant. So I know I'm looking for answers in the second and third quadrant. So here if I type in inverse of all this, I'm going to get this one, which is the first one, which would be pi. It would be 3 pi over 4. Okay? So 3 pi over 4 gives me this one. Notice my other one would be here, somewhere in quadrant 3. So I'm going to take 2 pi minus 3 pi over 4, and I'll get 5 pi over 4. So here, here's the second solution. So here, my solution for one period would be 3 pi over 4 and 5 pi over 4. Here, I can just literally take the arc, so arc cosine of minus square root 2 over 2. Will pump out the 3 pi over 4. So that pumps out the first one, then you have to deduce this one just based off of where cosine is negative. And then, so you say it's here, so how do I achieve that angle? It's 2 pi minus that angle. Okay? And then 3, if I want for all of them, so theta here can be equal to 3 pi over 4 plus 2k pi. And then also 5 pi over 4 plus 2k pi. And so that's for all. Alright, so let's do this one. So here I have cosine of 0.65. So it is written the way we like it. It won't always be, but for the first couple ones I'm always having step 1 completed. So here theta is equal to the arc cosine, because I don't even know what that is, right? So I'm just going to have to take the arc cosine of 0.65. I know this is in quadrant 1, because this is less than pi over 2, because pi is 3.14, so half of that would be about 1.5-ish, a little over 1.5-ish, and so this is definitely in quadrant 1. And so, and notice it's, no, hold on. Let me rewrite where we say that. This is a positive number, making the inverse cosine be in quadrant 1. Because inverse cosine of a positive number would be in quadrant 1. The inverse cosine of a negative number would be in quadrant 2. And so this is equal to 0.86, which now I know the 0.86 is in quadrant, this angle is in quadrant 1, right? So the inverse will give me something in quadrant 1. So here, let's go ahead and draw a picture so it'll make it easier to explain what I'm thinking about. So this is 0.86. So that's my first one. So what's my other theta? Well, my other theta is here, right? Well, how do I get that? Well, it would be 2 pi minus that angle, right? So it would be 2 pi minus 0.86, which gives me 5.2. And so I can here say theta is equal to, is roughly equal, I'm going to put the rough estimates in, is roughly equal to 0.86 plus 2k pi plus comma 5.42 plus 2k pi. So here's the two solutions right here. So one's here, the other one's here. So this, what I'm really finding is this angle here, which is 5.42. Or minus 0.86 is fine. So if you had a negative 0.86, that's the same as this. They're the same, right? And so here we have our solution. Alright, so let's look at tangent. So we've done sine and cosine a couple times. So let's look at tangent. So this is already solved. We're already good for that. Tangent tends to be a little bit easier, because notice that tangent can take anything, and then it's the inverse tangent gives you all the answers. And what do I mean by that? Because inverse tangent of 1 gives you 2, or of 2, the inverse tangent of 2 gives you about 1.12, and then I only need to add this. That's all I need to add for this. So this is 2, and then 3 would be, all the solutions would be if I add the k pi. And this is for tangent and cotangent, because that's what the period is. And let me explain why real quick. So here, between minus pi over 2 to pi over 2, tangent achieves, oops, let's make this my 0, so I can almost, this is what tangent looks like. And so it achieves all the values, right? And then it just repeats again. So if I'm looking for a particular value, say 2, right? Here I can just find whatever it is. The arctangent will give me that value, and it only will give me that value with an index period, so I don't have to worry about adding or subtracting. So in some way, tangent and cotangent are a bunch easier. And then the next time will occur would just be pi later, right? And then, or pi previous, or 2 pi later, or 10 pi later, right? Because this just repeats itself over and over and over again. So this tangent tends to be a lot simpler. You just take the inverse of it, get that, and then tack on k pi. That's it. Okay? I'll show you where it can kind of get a little more complicated than that, but let's go ahead and go to the next one. So here, I do not have this as a tangent value of this, so I'm going to solve for it. So we're going to do 2 sine of theta. I'm going to move my 1 over, so I get positive 1, and then we sine of theta equals a half. Okay, and notice we've already solved this, so this is the same as before. So here, I'll get theta of pi over 6 plus 2k pi, comma, 5 pi over 6 plus 2k pi. And notice we did this right here. So if you're wondering where those values came over, we did this nice and slowly in the first one. Alright, so this is a little bit more standard, what you'll see. And so I'm trying to work you up one step at a time. How do you deal with step 2? Right, here's step 2. Step 3 is just adding. Get to step 2. How do we deal with step 2? Here we're dealing with step 2. Still in step 2 mainly. 3 is just the adding. Here, dealing with step 2. Now we're dealing with step 1, getting us to step 2. So this is 2 and then 3. So let's find all the solutions. So these are find all the solutions. So let's do this one. So this one gets a little bit more complicated. Alright, so let's go ahead and do this. So here we'll have tangent square theta equals 3, or the tangent of theta equals plus or minus square root 3. And then here, if I take the inverse theta, I'll get 2 different answers. So the inverse theta of positive square root 3 is pi over 3. The inverse theta of minus pi over 3 is minus pi over 3. So minus pi over 3. So the arctangent of square root 3 is pi over 3. The arctangent of minus square root 3 is minus pi over 3. Then all we need to add here is add k pi, and that gives us all our solutions. Okay. So here tangent did have 2 solutions, but that fell out because I have tangent of the positive. Oh, I'm going right the other one. Of minus square root 3 equals pi over 3, or minus pi over 3. Okay. So here, if we crunch these 2 numbers, we can do that. I'm debating if I want to show you how to do that on the calculator. Nah, we're good. Alright, so here we have our solutions. Alright, so let's do some more complicated things. Once we get more complicated stuff, we'll be, and then here, so once we've got all the basics down, let me see, complicated is about as far as you need to go. That way you can see something kind of easy, something complicated, and you should be able to fill in the gaps in between. Not necessarily, but hopefully, right? So let's look at this. So here I have 2 cosine squared theta minus 7 cosine theta plus 3 equals 0. So this looks like a mess, right? But notice if it was just 2x squared minus 7x plus 3, instead of cosine we have that, we get this. I can factor that into 2x minus 1 and x minus 3. Notice here, if I put this together, I get, indeed, this is equal to 0. So this implies that 2 cosine squared theta, so this is the same thing as saying 2 cosine squared theta. And so in x, instead of x, we're going to have cosine minus 7 cosine theta plus 3 factors into 2 cosine theta minus 1. Same as before, just instead of x we have a cosine. And then we have cosine theta minus 3 equal to 0. Let's go ahead and split this up and solve them separately. So I have 2 cosine theta minus 1 equals to 0. So here, we're still on kind of step 1. We want to get this in such a way that I have something cosine on one side and everything else on the other. So what do we have here? So this is cosine of 2 cosine theta equals 1, or cosine theta equals a half. This one is cosine theta is minus 3 is equal to 0, so cosine of theta equals 3. Notice that this cannot happen, right? Cosine of theta can give values between minus 1 and 1. And so we just kind of throw this away. So there's no solution here. There's no solution here. Doesn't mean there's no solution for the entire thing. That means this can't be 0. So this had to be 0. Remember, the zero multiplication rule says if this times this equals to 0, either this was 0 or this is 0. Well, this can't be 0, so there is no 0. So, but this could be 0. And so the whole solution still has, even though this part has no solution, the whole thing could have a solution as long as this equals 0. And can we make this equal to 0? Sure. Can cosine of theta be a half? You betcha, right? And so here, cosine theta is of half at where? Well, at pi over 3, right? So if I took a cosine of inverse cosine of, hold on, make sure, just double check things, yeah. So we get pi over of a half, oops, positive half. And not, let's just try this again. Half will give us theta, which is equal to pi over 3. So that's in the first quadrant. Cosine is positive in the first quadrant and in the last quadrant. And so here I have pi over 3. So where's this one? This would be 2 pi minus pi over 3. Or minus pi over 3 would be fine. But just for sake, let's keep everything positive. So this is pi over 3. The other one occurs at 2 pi minus pi over 3, which gives us 5 pi over 3. And so here we have 5. Notice we want to solve the equation. So this is for all of them. So we're going to add 2k pi. And then here we have the 5 pi over 3. And so this is our step 2. Find all the solutions. Once we got it to here, which was our goal, we're going to find each solution. There should be 2. They should be here in the first quadrant and then here in the fourth quadrant. And notice here cosine is positive in the first and fourth quadrant and negative in the second and third. So if I had a negative number here, I want the inverse cosine to give me the second, I'd have to deduce the third. Since it's positive, it gives me the first one, I have to deduce the second one. In this case, it's just 2 pi minus that. Okay, we have plus 2k pi, or 2 pi minus the pi over 3, as we got here. So here's all my solutions. Alright, so let's find all the solutions of this mess, and this is a big mess, right? Alright, so here we can factor out a cosine, so let's do that. So I'll have cosine theta, and I'll have 5 sine theta plus 4 equal to 0. So let's find out all the answers here. So that means either cosine was theta equals 0 or 5 sine theta plus 4 is equal to 0. So cosine equal to theta equal to 0. Okay, that's nice and solved. So that one's done for this first step. Here we'll go ahead and move this one here, move this one over here. So I'll have 5 sine theta plus 4 equal to 0. Here I'll have sine of theta equals minus 4/5. Okay. Alright, so now I have this and I have this. So what I'm going to do, take the inverse cosine. Where's cosine 0? Well, it's at pi over 2, right? And the other part is at, so here, cosine is 0 at pi over 2 and minus 3 pi over 2. So this is the two answers here. So I'll get pi over 2. And then, oops, not positive 3 pi over 2. Okay, so it's this angle and this angle. So those are my 2 in my first quadrant. Here we're going to have sine of minus 4/5. And so if I calculated this number, the inverse sine So sine, if I took inverse sine of 4/5, I'm going to get minus 0.93. But notice, where is that going to give it to me? So that gives me an angle here. Like, okay, so that's minus 0.93. Here I want to find its corresponding angle in this case, which have the same reference number. So here, if this is minus 0.93, and I want to get here, so I'm going to go pi distance and then add 0.93. So here would be plus 0, so pi plus 0.93. So that's how I deduced my other angle. Notice there's multiple beginning angles here. Standardly, you want to write them in terms of the first positive between 0 and 2 pi, but since this already gave us a negative, we'll just leave it. And so pi plus, that would be 0.47. Alright, so now I have all my angles, and so just to write it all as all the solutions, and so I'm going to write pi over 2 plus 2k pi, 3 pi over 2 plus 2k k pi, plus, or minus 0.93 plus 2k pi, comma 4.07, roughly, plus 2k pi. Okay, and so that's how we solve these equations. So for these more complicated ones, like we have here and here, so try to solve it till you get some cosine or sine or some trig function equals a value. Here we did it twice, and then go ahead and do what we've been doing the whole time. And here I just factored out a cosine. Either this is 0 or this is 0, and this is usually how most of these run. Okay, so give these a try. You have questions, that's what the discussion boards or the flipped classroom is for. And have a good one. And that's the end of this one.